Hey everyone, welcome to my YouTube channel. The topic that I am going to explain through the presentation slides is the radio frequency integrated circuits, RFIC circuits. The content that I am going to cover in this presentation is the introduction of the RFIC, applications of RFIC, blocks in transceiver design, RFIC design structure, and what are the types of RFIC, and at the end I will conclude that topic, that is radio frequency integrated circuits. In general, RF circuits are also known as cell phone circuits or mobile circuits. Those circuits which can operate with radio frequencies, or the circuits having the electrical signals with frequencies, depending on the type of RFIC, having the range, it may be 30 megahertz to 300 megahertz or 100 megahertz to 3 gigahertz. It depends on the RFIC types, which I will discuss in the next slides. And it is mainly found, it's mainly used in mobile phones and wireless devices. As I said, that RF circuits are also known as cell phone circuits. So that's the introduction. Now I am going to discuss the applications that where these types are used. Actually, these RF circuits are designed for mobile phones, local area networks, global positioning systems, and these are the major advantages of the designing the radio frequency circuits. And here are the applications are there by using the integrated circuits. These integrated circuits are used in wireless communication systems. In wireless communication systems, radars, remote sensing devices, medical applications. So all these areas we are using the RFIC circuits. Major applications of all these are the wireless communications. So this is the RF building blocks in RF radio frequency transceiver design. LNA is the low noise amplifiers, mixers. We can also call it as the multipliers, or it allows the receiver to be tuned across a wide band of interest. It basically translates the desired received signal frequency to a non-fixed frequency. And then oscillators is also a very essential component in any radio frequency system. It serves as a signal generator in a transmitter. In a receiver, the local oscillator is used together with a mixer to convert the received RF signal to an intermediate frequency signal. So these oscillators can also be modulated by a low frequency analog or digital signals. And then the frequency synthesizers are used to generate the local oscillator signal in transceiver systems. And power amplifiers converts a low power radio frequency signal into a high power signal. Basically, that RF power amplifiers drive the antenna of the transmitter. So this is the architecture design of the radio frequency system. Basically, it consists of two sections. One is the receiver and the other one is the transmitter section. So in transmitter section, we are giving the input in the form of wireless data system, and giving the input in the form of an analog system. After passing through multiple blocks or multiple stages, we can get the output in the form of an analog relay. Here in transmitter, analog to digital converter, and in receiver, digital to analog converter. It just converts the analog to digital data. Signal compression basically reduces the amount of the signal, and here in the receiver section, signal decompression functions as the opposite of the signal compression. Coding is basically receiver can easily detect the input signal, and decoding acts as the reverse operation of the coding. Um, Basically, it reduces the errors through decoding. Here in transmitter section there is a pulse shaping block stage where it will just change the shape of the transmitted pulse, and in up conversion it will just enhance the low to high frequencies. And here in receiver section we have down conversion, which enhances the high to low frequencies. And at the end of the transmitter, that power, there is the power amplifier, which is the last stage of the transmitter, and its main function is to amplify the weak signal, or is to convert the low frequency power of the low frequency signal to the power of the high frequency. So it's basically function is to amplify the signal until required or sufficient power is achieved. At the first stage of the receiver we have low noise amplifiers, which purpose is to strengthen the signal by reducing the noise. It basically does not reduce noise levels, instead it handles the noise. And in equalizer, as the name describe its meaning, that it balances the frequencies. So for balancing the frequencies, as the signal is passing through multiple stages and there are different kinds of frequencies and we have to balance the frequency, so we are using the equalizer for this purpose. So here are the types of RFIC. First I am going to discuss that is the low frequency RFIC. As its names describe that these types of circuits, radio frequency integrated circuits, are operate at low frequency, and their frequencies ranging below 30 megahertz. And it is used where where we have required the accuracy. So it is used in those applications where low frequency RFICs are used, as the electronic temperature control and oscillators and complex phase locked loops. Electronic temperature controllers are used with refrigerators or freezers, or like these types of appliances. So in these types of appliances, in this electronic temperature controller, we have used the low frequency RFIC circuits, and in oscillators and complex phase locked loops. Here in the picture we see the phase lock loop, where we have given the input of the reference frequencies, and we get the output in the form of the uh, nth frequency divider. And if there's different frequencies of the if the different frequencies are like locked together, or different frequencies are of same phase difference, so they are locked together between them, and their phase differences between them is like 180-degree. So we have named as the locked loops. So this is the complex phase locked loops. This type of RFIC is also known as the low noise. And this type is medium frequency RFIC. Uh, in this type of RFIC circuits, we have the frequencies that is ranging between the 300 and between 300 and 3000 megahertz. And applications where these medium frequency RFIC circuits are used is television, radar, and satellite communication. It is used where we have required the high level of performance and accuracy. So these medium frequency RFIC circuits are used. So these high frequency RFIC circuits are used where the with the applications which require which are having the high frequencies, and the frequencies ranging between 30 megahertz to 3 gigahertz. And these high frequency RFICs are basically used where the high level of performance, accuracy, and is required, and also the voice, or also the communication which is free of error or free of distortion. So these high frequencies are used for this purpose, and these applications include cell phones and walkie-talkies.
To help meet that need, GTRI researchers have developed a new integrated circuit that enables the direct processing of microwave and millimeter wave radio frequency signals. The IC meets the need for high-frequency, wideband analog electronics for specialized applications that have small form factors and challenging weight and power budgets. Known as a transversal radio frequency filter integrated circuit, or TRAFIC, the device has been used to create a finite impulse response filter that operates in a frequency range of 2 to 20 gigahertz. TRAFIC was fabricated in silicon germanium technology, a platform designed for high-performance, mixed-signal, and analog designs. TRAFIC chips can be placed close to antennas, where they filter out unwanted high-power or out-of-band signals before they enter digital signal processing. That can improve the ability to process low-power signals of interest by preserving the dynamic range of the incoming signals. It also reduces processing delays. TRAFIC was designed to be highly reconfigurable, offering flexibility that in the past has been provided by a power-hungry digital processor. In Atlanta, I'm John Toon with the Georgia Tech Research Institute.
Here is a video that describes that how RFIC circuits are working in aircraft system. So look at that video that I am going to show you. If you have any questions, you can comment it down in the comment box, so I will answer them.